Hello and welcome. Coding in Java, Part 1. So this is going to review some fundamental coding ideas in the computer language Java. So why would you want to learn to program in Java? Well, it's really popular. A lot of people use it. But some other reasons are it's object-oriented, meaning you can break the code up into discrete chunks and use those over and over again in the form of classes and so forth. It's open source, meaning it's free. Nothing is, you don't have to pay for any Java. And it's community supported. So here's a website that has a Java community forum that you can get on and post questions and answer questions and so forth. Alright, so let's get to it. We're going to use Replit, so if you will, go to repl.it and sign up at Replit. I want you to once you're logged in, create a new Replit and name it Coding in Java Part 1. So if you need a few seconds to do that, feel free to pause the video here and come back when you're at that Replit screen where you're ready to code here. Alright, some Java structure. So Java structures is quite different than Python, the language I discussed before. You're going to need this class main argument in the beginning. So and by default your Replit is going to begin with this because this must always be present for any Java program, and this class name has to be the same as the file's name or you're going to get some errors, so make sure that's the case. And I'm also, you notice this import because I'm going to use some Java utilities. So before I begin the class, the main code block, I've used this import to add some features to the default Java package that we're going to use later on. So import java.util.*semicolon. So that's going to import all the Java utilities package we'll need for some of the code we're going to do. Alright, so between this public static void main is going to be present again in all Java classes, and it's going to represent our main code block. So everything between this open brace and this closed brace is our main code block, and this is what's going to execute. Outside of this is where you would define methods, which we'll get to in a little bit. And then this, of course, would be the end of the entire class, which is another way to say the whole program, if you will. Alright, so the structure of Java is, this is sort of like a template that wraps around the executable statements, which will go here in the main code block, and they must always be followed by a semicolon. So you'll probably see me miss one or two of those because I'm not totally used to it. I'm more accustomed to languages that don't require that, but you must always have a semicolon after every statement in Java. So let's talk about primitive data types. So this is data that holds one value, and the first one we'll talk about is an integer. So primitive data types, and the first is integer. So that's a number without a fractional part. Alright, with Java, unlike Python and some other languages, you must declare the integer type the first time you assign a value to that, or any variable for that matter. So you must declare a variable type when you first assign that variable a value. So you can't just say x equals 5. You have to say integer x equals 5, and don't forget your semicolon. So integer, you must declare the type. Now after you've declared it, you can reassign it, no problem. You don't need to declare the type after it has been initialized. But the first time you declare a variable, you must declare its type as well. And in this case, we're going to use integer, meaning a number without a fractional part. And it uses this int. Let's make another one here. Int y equals -42. And then we'll make another one. Int z equals x plus y. So you'll notice that that's a I've used these variables here and I didn't declare their type. Well, that's because they've already been initialized. So the initialization only need occur once. After that, you can use them in a more intuitive way. You don't have to worry about the declaring their type. So anyway, that's integers, numbers without fractional parts. Another primitive data type is a double. So we called numbers with the fractional part floats in Python, and floats exist in Java, but they are smaller than doubles in terms of how much memory they reserve. So doubles are more commonly used. Floats are a little more memory efficient, but because they're effectively interchangeable in most programs, you might as well go with the one that is more exact, and that's the double. So the double, and I'm going to call this one A, equals 2 point blah blah blah. So there's an example of a double. Double B equals 0.09 blah blah blah, and we'll say double C equals A divided by B. So if I run this code, we will see no output in the console here. And that's okay because we have no output declarations. You remember, all this takes place, variable assignments takes place in the background. They're not announced to the console by default. We have to print them to the console to see the output, which we'll do later, and it's a good way to debug your code and understand what the variables values are in certain places in the program. But again, we'll get to all that in a minute. For now, we're just assigning the values and letting the computer take care of that in the background. The third type of primitive data we will discuss is the Boolean. And this is a value that is either true or false. And just a quick note, in Java, true and false are lowercase t and f. In Python, they must be uppercase, but in Java, lowercase t, lowercase f. So I'm going to say Boolean j equals true, and Boolean k equals false. Let's make another one. Boolean O equals 12 greater than 14, which will of course be false. Boolean P equals 42 is less than or equal to 100. That would of course be true. Don't forget your semicolons here. Alright, so once again, we'll print these out, or we'll run the code and nothing will print out because all this again taking place in the background. All these variable assignments occur without any output to the console by default. Alright, and the fourth type, this is not technically primitive. It's a string. So it's a fundamental data type, but it's again not technically primitive. This is a valueless, at least mathematically valueless, set of characters. So string s equals, and oh, if I have a variable assigned already, let's just do this. I'm going to show you how this would throw an error. So string a equals hello. Now notice I've already initialized a as a double, so watch what happens when I try to reinitialize it as a string. Ooh, doesn't like that. So you cannot reuse a variable as a different type. Doesn't work that way, so you have to come up with a different name. Alright, so we'll call this string s equals hello. And no problems. Actually, forgot my semicolon, but no problems with s because it had not yet been used. Alright, so let's make another one. String s2 equals 12423, and string s3 YOLO. Oops. And again, we run that. Nothing happens because we have not declared any outputs. What did it not like? Oh, forgot to capitalize my string. Sorry. Yeah, it must be capitalized on string or it doesn't work. And you might say, wait a minute, the other ones didn't have to be capitalized. You're correct, and I'm not sure why that's the case, but in Java, you have to capitalize string, but not the others. And notice also it doesn't turn blue, so that's also different and weird. I'm not sure why. Okay, so let's do a task, shall we? Let's see here. So task number 1, create a string named myString that is equal to hello world. Create an integer named myAge that's equal to your age in years. Create a double named myDecimal and set it equal to as many digits of pi as you can remember. And create a boolean named myBool and set it equal to true. So do these 4 tasks, pause the video, do these 4 tasks, and then come back and we'll review them. Alright, welcome back. Let's complete these 4 tasks now. So here we go. Notice I've commented out the previous code, and again you can do that by highlighting any section of the code, holding control and hitting / that comments and uncomments out the code as a shortcut. Alright, number 1. Create a string named myString that is equal to hello world. Now this uses the Python naming convention, which is with underscores between words. More common in Java is what's called camel case, which is where you mash it all together and every new word you just capitalize. So we use the Java convention. They're both legal ways to name variables in both languages, but again, the first method is more common in Python, and this camel case method is more common in Java. Whichever one you choose, you should stick to. And we need to declare this to be a string. String myString equals hello world. Alright, create an integer named myAge, int my_age equals 44. Don't forget your semicolons now. Told you that would be a struggle. Double named my, and also let's switch to the camel case here. Again, whichever one we do, we want to try to be consistent. Alright. .141592, I think. Don't know anything after that. So my decimal is now assigned. Last one here is boolean named myBool. Once again, we'll convert that to the camel case naming convention. And we need to declare the type. Boolean myBool equals true, lowercase t. Okay, so we run this. Once again, we're not spit down anything over here, and that's to be expected because we have no outputs, so just the variables being assigned. All that goes on in the background, so nothing happening that we can observe. But let's change that. So let's talk about some output methods. So there are 2 basically ways we're going to print to the console. So they are with system dot out dot print, and then system dot out dot print ln. So they do similar things. So this one is going to print whatever the argument is. So in other words, what's between the parentheses. So what this print ln is going to do is print arguments and advance to the next line. So it's going to print and then go to the next line down, which is going to look very similar. These are going to print on the same line because this one's going to print It's not going to advance a line. Then it's going to print this one. Then it will advance a line. And I'll put another one down here so you can see that that next one will be on the next line down. So it's going to say ha ha ha, ha ha ha. Okay. So prints only, and the ln prints and goes down a line. All right, already time for another task. Let's do it. So what I'd like you guys to do is print out all the variables you created for task 1 on separate lines, and then print out all the variables you created for task 1 on the same line. Pause the video and take care of that, and then come back and... All right, welcome back. Here we go. So first of all, print them all out on separate lines. So we're going to use the one that prints and advances a line. Remember, that was this command. And so we want to first print my string. So then we had my age. Then we had my decimal. Then we had my bool. So this is going to print out all on different lines. And I commented out the previous print commands so they didn't confuse us. So here we go. Hello world 44 3.141592 and then true. So that is my string, my age, my decimal, and my bool respectively on separate lines. Print them all out on the same line. That's going to be pretty easy. The only thing we need to change is get rid of that ln bit, and now it's going to smash them all together. So it will first print them on separate lines because of these series of commands, and then our second task will be carried out right here, and I can make that a little bigger, and you'll see that it is actually on the same line. It's just a consequence of we had it squashed when we ran it, so it did wrap around to the other line. I'll run it again to show you what I mean. Now, so you see now it's on a single line in that second case. Okay. Next, let's talk about console inputs. So what if we want to gather some data from our user? I'm going to comment out all the old stuff here. So none of that code is active. And remember, we had this import, so in order to use the feature I'm about to use, you must have this import command before the class main. Alright, so we're going to say scanner, scan. So the first is the type. So this is an object in the class of scanner, which is a variable type. Scan is equal to new scanner. Alright, so it should be new scanner, and then in parentheses system.in. Don't forget to end with a semicolon. So this declares that the variable scan is an object in the scanner class, and it will operate with these parameters. So we can use that to get information from our user. So if I say variable, let's say string str equals scan dot next line. So there are several different functions or methods I need to use with respect to the scanner, and the first is next line. This is when you want to get a string from your user, and then I'm gonna print it right back out to them. Okay. So you'll notice over here in the console we've got a well, I didn't put a prompt in here, so it's just saying type something. So I'm going to type hi, and then it prints it right. All right, so, and instead of, just that blank prompt, we can print out something ahead of time and say, what do you say? Question mark. And we're going to do the print line here because we want it to advance down to the next line. Just looks better that way. So now we're going to prompt the user, what do you say? And it's going to come up with an input box in the console that we can put our answer in, and then it's going to print that right back out to us. Sometimes Replit takes a second or two to run here. What do you say? I'm going to say hi, and it's going to say hi back. All right, so that's getting a string, is this syntax. What if I wanted an integer? Well, let's make a new scanner, and I'll just copy the code we already have here, and I'll call this one scan2, and I can copy a good portion of this too. Okay, so, and remember this section is inputs, getting inputs. Okay. So we'll do another prompt here, and we'll say, what is your favorite number? And then we'll say integer num equals scan2, because we're calling the next scanner. If you've already used a scanner to get a string, at least on Replit, it doesn't seem to like it if you then try to use that same scanner to get an integer. So just made a new scanner to forestall that error. Next, int this time. Notice that's different. So I'm asking for the next integer the user inputs. And then we'll print out right back to the user again that number. Okay, so again, sometimes Replit takes a second or two to run, no big deal. What do you say? I say hi. Hi. Now, don't like the way it didn't advance to the next line, so let's fix that. Might seem like a trivial problem, but I like formatting. What do you say? Hi. Hi. What's your favorite number? 77. And then it says it back to me. Okay. What if we wanted all right, so if we want a double, it's going to be very similar. We'll say, what's your favorite decimal number? And then let's make another scanner. I think scanner 2 would probably work, but just to take the doubt out, we'll do scan 3. And instead of next integer, this time we want next double. And, okay, so that should run. Replit's taking its time again. That's okay. I think we got disconnected and reconnected here. So as soon as it processes the code, does not like that. Alright, so this actually has to be a double, or we'll get an error here. So we've got a string, we've got an integer, we've got a double, next double from our user. Let's run this. Hopefully Replit will cooperate here. Oh, we've already used number. Let's make this number 2. Oh, and then I've got a print number 2 here. Alright, now I think we're finally ready to go. What do you say? Hi. Hi. What's your favorite number? 77. Decimal number 1.618. Yeah, it says it back to me. Okay, so calling for user input. Be sure to always declare types. Okay, so let's do a task here. Your task is going to be to ask the user for their name and store it to a variable named username. And let's change this to camel case convention. Print out a personalized greeting using that name. Ask your user for their age and store it to an integer named user age, and then print out how old they will be in 2050 using a simple math expression. So take care of that and pause the video, come back when you're done. Okay, welcome back. Here we go. So notice I've commented out everything except for this. I've left that in place because we'll need one of those scanners at least. Ask your user for their name and store it to a variable named username. So string username equals scan dot next line. So that's going to ask the user for their name and store it to a variable named username. Okay, now print out that name in a personalized greeting. So hello, and here we're going to concatenate, which is adding strings together, but it's not adding like in math. You're just attaching one to the end of the other is what concatenate means. So we're going to concatenate this with username, so whatever they type in, it's going to be what comes out there. So hello username, I hope you have a great day. All right. I think my commas are correct there, although they might not be. Ask your user for their age and store it to an integer named user age. So I'm going to say integer user age equals scan2 dot next integer, and then print out how old the user will be. So let's see here. You know, Python is real finicky about numbers and strings being together in a single argument for a print command. Java handles that much better, in my opinion, and you don't have to worry about mixing up variable types in a argument for an output. It'll just make it work by default. Java does. Okay, so we're going to say you will be plus, and now we want an expression. So how old will you be in 2050? Well, that's 29 years from now. So we'll say user age plus 29. Probably the simplest way to do that. And then another string in 2050. So let's see if we've accomplished all our tasks here without any errors. It tells me I forgot a semicolon here. Told you that would be a struggle. Oh, capitalize next in next line. It should be lowercase n and uppercase L. Computer code is very finicky and case sensitive, so any sort of mistyped letter whatsoever is going to throw an error in your code. So be prepared to do a lot of debugging, as you just saw me do. It's a very important and essential skill. Alright, so our code here is requesting from us a string, and I'll put in my name. We should have really prompted the user, and here it's requesting a number, our age, and I put it in. It tells me I'll be 73 in 2050, but let's clean that up a little bit and do some prompts so that makes a little more sense. We'll say, what is your name? we'll say, what is your age? Okay, should make a little more sense now. So, what is your name? Put my name in here. And what is your age? And again, tells me I'll be 73 in 2050. Okay, so there's those tasks accomplished. Next, let's talk about something called arrays. So arrays are similar to lists in Python, but we need to declare the type of things that are going to be in our arrays before we assign them. So let me comment out everything we've got here. And we'll start a new section of our code here. We'll call this arrays. So these are lists of things. Collection of values of a same type. So first of all, let's make one involving strings. So I'll make a string array. I declare the variable type, but instead of moving on, we're then going to put the open closed bracket, and that tells it that it's an array of strings, not just a string. And we'll call this cars, and then we're going to use the braces to enclose our values, so like so. And then I'll go ahead and put that there. And we're going to separate these with a comma. So I'm going to put a Ford, Chevy, Toyota, and Nissan. Alright, so running this code doesn't do anything because we haven't called for any output, but here is the array. Let's make another array of integers. So integers, but again followed by those brackets, and we'll call this one I don't know, my numbers. And once again we'll put braces around our values, and these are integers, so we won't enclose these in quotes. There we go. And let's make them a little more unusual so they'll be easier to distinguish from the index values. Okay, so calling an element of an array. Remember that the index starts at 0. So if I just do a print command, and I'll print the whole thing. Let's see what the output looks like there. Okay, so not great. Yep, so Java doesn't give us a meaningful output that way. Instead, we want to call an index value. So let's say we want the 0th item. So this will be indexed 0, 1, 2, 3. So there will be 4 items, but they start with 0. So they only go from 0 to 3. So if I print that, that'll give me the first item on the list, which is Ford. Sometimes Replit takes a while again, no big deal. There it is. Alright, so let's do that for all of the items in that list. And I'll change this to 1, this to 2, and this to 3. And that will print out all the different values of the array respectively. There we go. Okay, so let's do something similar with my numbers. So if I made this 3, can you predict what would be printed out? Remember, it indexes at 0. Oh, let's see, what did it not like? Oh, numbers. Put an S on there. That's the kind of thing you have to go back and do all the time in computer programming. Any sort of mistyped word will not parse. Alright, so if you predicted 40, you are correct. It is the fourth item, even though it's the third index, because again, we start at 0. So in indexing arrays, lists of things, the index starts at 0. Those are some things to remember. Alright. Let's talk about finding the length of a list. So let me add a couple more cars to our list. We'll say Mercedes, and we'll say Volvo. That'd be good. And let's imagine we want to know the length of that list. I can use the length method. Like so. And that will print out at the very end here the length of that list. And there's none of that indexing at 0 business when it comes to the length. It starts counting at 1. So 1, 2, 3, 4, 5, 6. 6 elements in our array cars. And that's called with this length function. Often we want to iterate over everything in a list. So it's very important to know the length of the list in order to do that. So this is a method you're going to use a lot when we're working with arrays later. Okay, multi-dimensional arrays. We'll talk more about these going forward, but you could have more than one dimension. So if I were to make a multi-dimensional array, let's say I want a two-dimensional double array. We'll name it that, and we'll say this, but because it's two-dimensional, we need 2 sets of brackets inside our outermost brackets, like so, and they should be separated with a comma, and these will be the 2 dimensions of our list. Like so. Okay, so calling elements in a multi-dimensional array is a little bit more complicated. So we've got each of these, think about this like a row, and if I set it up like this, it'll make more sense. So each time you have a comma in here, that's like a row, and these are columns. So let's say I wanted to call this element. So you see how it's the second row, second column. So if I wanted to call that element, I would say mynum2. Alright, so what I want to call here is the second row, second column. But remember, we index from 0. So 0, then 1, 0, then 1. So this is going to be the second row, second column. But remember, we index from 0. So we put a 1 there as the second element. That could be very confusing. And it does indeed call 14. And because I named it a double, do you see how it adds the 0.0 at the end? Isn't that interesting? Let's add a couple more values. These do not have to be the same width. Alright, so now we've got some more size here. This will be the 0, 1, 2 row, and let's pick the 0th item here. So that should be 1.2. So remember, the first number here is the rows starting at 0. 0, 1, 2. And the second number here is the columns starting at 0. 0, 1, 2, 3. Oops. And so on. 3. So if I did 0, 3, it would call the 4th item listed in the first row, which is 19. Okay, so let's imagine I want to change a value. So see how that's 19 there? Let's change that to negative 52.1. Don't forget your semicolon. Now let's print it out again. Yeah, see now it's negative 52.1. So we can assign values, and they don't have to be multi-dimensional for this to work. I could do this up here as well. I could change one of these car values using just the one index value. Alright, so task for you guys. I would like for you to create a string array called myfaves. Once again, let's change that to camel case, just for consistency's sake. And include your 5 favorite things as strings, then print the list out one at a time using index values. Then I want you to change something on your list, and then print it out a second time to see how it changed. Alright, so pause the video, take care of that, and come back. Alright, welcome back. Let's complete these tasks. Let's see here. Got some extra stuff on there. Alright, here we go. So, create a string array called myfaves. So, string, capital S. Oop, got caps lock on, I guess. There we go. Don't forget your open and close bracket to indicate that it's an array. Don't forget this open and close brace, and we'll put in programming. Try to be consistent with my casing here. Put in teaching. And the last thing I'll put in here is sleeping. Alright, so now we want to print out that list one thing at a time. So I'm going to use the system.out.println. And for the argument of the println command, I'm going to say myfaves, and then I'm going to use the index 0 for the first thing. I'm going to copy that, paste it over and over again. And then I'll change that index to 1, 2, 3, and 4. Remember that because we start at 0, this is the first thing, the second thing, the third thing, the fourth thing, and the fifth thing. Replit taking its time again. That's okay. Here we go. All 5 things printed out. Now let's change an element. So I'm going to say myfaves 5. I'm going to change that to woodworking. And then it says, don't forget your semicolon. And then it asks us to print it out again. And we'll note that change. So the second time it prints out here, you'll see when it gets around to it that index 5 out of bounds. Oh, derp, I meant to say 4 here. My bad. Try again. That goes to show you can't assign a value to something that wasn't there when you initialized it. Here we go. So you notice the second time it prints out that 5th item is woodworking. Okay, next topic. Let's talk about definite loops. These are loops that happen a certain number of times, and we're going to use the for command for this. And then we're going to need 3 things, and they're going to be separated by semicolons in the parentheses that come after 4 here. The first thing is the initialization of a variable. Usually you want to use an integer, and you want to give it a starting value. So that's the first thing. The type of variable and a starting value. And then a condition for that variable. Let's say I less than equal to 10. And then you want to iterate that variable, how much you want it to go up or down by each time. And I'm going to say I plus equals 1. I could also do this. In Java, that means the same thing as plus equals 1. And they both mean to add 1 to it each time. Alright, so this is our syntax. And the statements inside those braces occur each loop. So here we're going to have a loop that starts at 1, goes to 10, so it's going to happen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 times, and going up by 1 each time. So let's just print out something, and let me comment out this old stuff. All right, let's see here. System out. We'll say loop number, and then plus, and I'll use I. So that's the variable of iteration, the one that changes every time through. So it's going to say loop number 1, loop number 2, loop number 3, and so on, all the way to 10. As soon as it runs here, just waiting patiently. There we go. What if I said 100? Well, the computer doesn't care. Remember the long time ago in that very first lecture I posted, said computers are inexhaustible. They'll just do whatever you tell them to do. They'll never stop. They don't care. So it'll go to 100, no problem. What if I put 1,000 or 10,000? We won't do it, but it would happily carry out that task until it completed. Even if I put 1,000,000 or 1,000,000,000, it would go until either the computer ceased to function or the software goal was accomplished. All right, so what if I wanted to go up by 2 each time? So let's change some values here and see how that changes the behavior. Let's say I want to start at 0 this time and go to 100 by 3s. So it's going to print 0, and then 0 plus 3, and 3 plus 3, and 3 plus 3 plus 3, and so on. So 0, 3, 6, 9, 12, and so on. Stop at 99 though, because 102 would not meet this criteria. So it's going to go by 3s from 0 to 99. Oh yeah. So 0 to 99 by 3s. What if I put 4s? Well, that's going to stop at 100. It's going to go 0, 4, 8, 12, 16, 20, so on, all the way to 100. 100 is divisible by 4, so it will land exactly on 100. There we go. What if I change this number to 99 and I tell it go by 1s? Well, it's just going to print 99 and then 100. Because we're telling it to start here. Alright, so 1 to 10. We'll leave it like that. Alright, so hopefully you get the idea on that. Some of the things we can do with for loops is populate arrays of numbers. So let's create a blank array with 11 empty spaces for integers. And we'll do that with this syntax. So integer array, and we'll call it numbers, is new integer array with 11 spaces. Alright, and then we're going to create a for loop that populates it. In other words, puts values in there. And we're going to do that with this syntax. So for integer I equals 0 to I less than or equal to 10, and I'll comment out this old stuff so it's not cramping our style. By 1s, numbers I equals I. So whatever the variable of iteration is, it's going to plug that in. This won't have any output just yet. I'm just making sure there's no errors. Yep, no problems. Okay, so now let's print out each value of our list. So we're going to say for, let's use a different variable this time, j equals 0, integer j equals 0, and j less than or equal to numbers, and I'm going to use the dot length method here. So that's going to go until the number of things that are in that array, and we'll go up by 1 each time. We're going to print, no, system dot out dot print the numbers j. assuming we got all our syntax correct, it should give us a list of everything on that in that array. Didn't like it. Oh, out of bounds. Oh, shouldn't have equal to here. There we go. Because you remember start at 0, so it stops at 1 less. So that equal to caused us to go outside of the index range. Here we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I do ln here, it'll print it on different rows. So that might be more visually appealing. And I'm not confined here to just the value. I can do mathematical operations to it. So let's say I wanted to start at 1 and go to 11, which would still be 11 entries. And let's say I wanted to populate it with squared values. Could do that with I times I. What is it not like here? Index 11 out of bounds. Oh, did I do something with that or equal to again? Yeah, I think so. I think I need to make that a 12. Yeah. Yeah, we still got an index here. Let's think about this. So we got 11. So 1 to 10. I think that would do it. Let's just leave it like that for a second and make sure that works. Oh, I know what the problem is. This should be -1. There we go. Okay, figured it out. Yeah, because we're starting at 1, we want to start with 0 on the index, so I need to take 1 away from it here. See how tricky that indexing at 0 can be? There we go. So perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. From 1 to 11, perfect squares. Okay, so little task for you guys. Alright, so I want you to use the list you made in task 4, my faves, and print out each element on individual lines using a for loop. Create a for loop that creates an array from 1 to 100. Create a for loop that creates a list of even numbers from 2 to 100. Create a for loop that runs 5 times and asks your user for their 5 favorite movies and then prints those out nicely formatted to the console. Alright, so see if you can accomplish those tasks. Pause the video, come back, and we'll group. Okay, so let's talk about this task here. Using the list you already made, print out each element on individual lines using a for loop. So 4, and we'll use I, integer I, equals 0. We want to start at 0. Remember, that's where indexes begin. And I is less than the length of my faves. So I call the length method on that. And we want to go up by 1 each time. And we want to print, no, forget that, system dot out dot print ln, go into a new line each time. And we want to print out my faves I. Alright, let's check that. Missing a semicolon. Bummer. There we go, no problem. Okay, next task. create a for loop that creates an array from 1 to 100. Well, we did it for 11, so we'll just use that same code. And we want this one to have 100 spaces and 100. So from 1 to 100, going up by ones. I believe this will do it. Oh, well, we still got it squaring the values, but it did do what we wanted. It just recorded 100 perfect squares instead of 100 integers. This time it should work. Yeah, there we go. 1 to 100. And we printed everything out on its own line. So we went above and beyond there. How about a list of even numbers from 2 to 100? Well, okay, so we got a plan here. So we got from 2 to 100, going up by 2s. And what we want to do is populate this list. So let's see, numbers 2. And then I have to be careful with this index because I want it to start at 0, then go to 1, and then 2, and so on up to 50, or up to 49. So how in the world would I do that? Well, I think I've figured it out. If I take I divided by 2 and then minus 1. So it starts out with 2. 2 divided by 2 is 1. Minus 1 is 0. And then it'd go to 4. 4 divided by 2 is 2. Minus 1 is 1. Yeah, so I think that would work. And we'll set that equal to I. So I think that'll do it. And then we'll do the print out business here. Except instead of numbers, it's numbers 2 this time. And I'll comment out the old stuff so it doesn't confuse us. So here we go. We have to clear out this. Need a semicolon. There we go. Even numbers. So 2 to 100. There we go. Perfect. All right. Now task 4 is going to be to create a for loop that runs 5 times and asks the user for their 5 favorite movies. All right. So let's create an empty list first of all. Capital S. And we'll call it MOVLIST. Move list. Alright, and then we'll populate that. So we'll say for integer I equals 0, I less than move list dot length plus plus. So that's going to run a for loop once for each element in that list. And we're going to say, and we also need a scanner. Make sure I still have that. Yep. So let's get some of our code we've already created here for a scanner. And then we'll steal some of our earlier code again. Just to make our lives a little easier. Inside our for loop, we're going to do this. So string MOV. And so we want to prompt our user first, so it makes sense. Let's do it this way. What is your number? We'll do I plus 1 because that way it'll be 0 plus 1, 1 the first time, then 2, and so on. Alright, and then we need to add it to our list as they make it. So we'll say MOV, LIST, entry I equals MOV. And then after that's done, we'll just print out everything in I. We'll use some of our previous code again for that. Okay, so let's see how it works. Forgot a semicolon. What a surprise. What does it not like here? One error. Oh, did I forget another semicolon? My goodness. One of these days I'll start remembering those. But not today. Number 1 favorite movie, I'm going to say Predator. Number 2 favorite movie, Aliens. Number 3 favorite movie, Back to the Future. Number 4 favorite movie, Conan. Number 5 favorite movie, Rambo 3. And then it prints them all out. Yes, mission accomplished. Alright, ladies and gentlemen, that concludes this lesson. I hope you guys enjoyed it. I had a good time making it. And I'll be back again in Coding in Java Part 2, so if you want to continue to advance your knowledge of Java, be on the lookout for that one. Thanks, guys, and I'll see you next time.